In this video, we will be finishing up the Lesson 7 packet, specifically pages 5 and 6. And page 7 is something you need to do on your own to get credit for. So Lesson 7, let's just recap. Boolean values can only evaluate to true or false. So a Boolean was a new type of data that we discussed. We now have number, string, image, and Boolean. We opened a program which involved a butterfly named Sam, and our job was to write the code that would keep Sam safe on the left and safe on the right side of the screen. So where we left off, we had written the code for safe left, and we had written the code for safe right. You tried this on your own and should have checked to make sure that yours looked almost exactly like mine, except you could have had two different numbers for your inputs. So at the bottom of page 4, it says, let's test our safe left and safe right functions. Are they doing what we expected? What I have done is I have already typed in the code for safe left and safe right. So I'm actually just going to look at the cage program. I'm going to delete out these two lines of code and paste in the safe left code that I've written, the two examples and the definition. Notice the contract and purpose statement were already in the code. So when I click run now, we see Sam, he starts out at the same coordinates as he always does, 320, 240. I'm going to hold down the left arrow and let's see if Sam is now protected on the left side of the screen. If I'm holding down the left arrow, we notice that Sam's wing is still visible. So in Sam's mother's eyes, Sam is still safe, even if we can see a tiny part of him. So since we can, and I hit left, 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 he's not going anywhere, our safe left code works. Let's check to see if our safe right code works. I'm going to delete out these two lines of code and paste in the code for safe right that I've already typed. Again, it's two examples and a definition because the purpose statement and contract were already written. Now when I click run, we know that safe left works, so I'm hitting the left arrow. He's protected on the left side of the screen. We've written the code for safe right, but what do you notice what happens when I move him toward the right side of the screen? He goes way off the right side of the screen. So at this point, our safe left code is working and our safe right code is not working. So we can fill in a yes here, which is good, and a no here, which is not good. We need this to work. So what we're going to work on in this video is how do we get the safe right code to also work in addition to the safe left. That brings us to this concept of and or. So what happens when you want to combine true-false tests to see if more than one thing is true at a time? We are going to be applying this to the fact that we want safe left and safe right to work at the same time. We don't want just one or the other. So number 16, consider the following statements. Are they true or false? Sugar is sweet. Obviously true. Ice is hot. Obviously false. Ice is cold. Obviously true. How about when we take combinations of these sentences, either combining them with the word and or combining them with the word or? So sugar is sweet and ice is cold. We know that sugar is sweet is true. Ice is cold is also true. So if we have true and true, the whole thing is true. What about this other and sentence? Sugar is sweet and ice is hot. Sugar is sweet is true. Ice is hot is false. So what if I have an and statement where one part is true and one part is false? That makes the whole thing false. So and will return true only if both inputs are true. What about when we have an or connecting two statements? Sugar is sweet or ice is cold. Sugar is sweet is true. Ice is cold is also true. If I have true or true, both parts are true, the whole thing is going to be true. What about sugar is sweet or ice is hot? Sugar is sweet is true. Ice is hot is false. So if I say a statement that has a true and a false, but it's connected through the word or, the whole thing is true. So we find that or will return true if one or both inputs are true. Okay, so and statements need both parts to be true, and or statements only need one of the parts to be true, for the whole thing to be true. So when we write our circles of evaluation down here, number 17, and then convert them to code, we're also going to be evaluating them to see whether these statements are true or false. So 2 is less than 5 and 0 is equal to 6. The main function used here is AND. Our first input requires its own circle of evaluation. 2 is less than 5. 2 is less than 5 and 0 is equal to 6. We need another circle of evaluation for 0 is equal to 6. So that's my circle of evaluation for number 1. Written in code, I'm going to open my parentheses. AND is the main function. The first input is 2 is less than 5. I just have to write that in correct code. So 2 is less than 5. The second input, 0 is equal to 6, written in correct code. And then close the parentheses for the whole line. What we find here is that the computer is going to return a Boolean for this. It's going to be a true or false. So 2 is less than 5 is true, and 0 equals 6 is false. What will the computer do if we're asking it to give us true or false for a true and a false? Well, let's check it. I've typed in our first piece of code here and I'm ready to evaluate. I hit enter and it gives me false, which tells me that when I try to evaluate an AND statement where one part's true and one part's false, the whole thing will be false. Let's take a look at number 2. 2 is less than 4 or 4 is equal to 6. I want you to pause the video now and accomplish this example on your own. We'll check back in a minute to see how you did. So we want 2 is less than 4 or 4 is equal to 6. So that's our circle of evaluation. Written in code, it should look like this. And when we go to actually evaluate this, let's think about it first. It's an OR statement where 2 is less than 4 is true and 4 is equal to 6 is false. So this time we have a true and a false, but it's connected using the word OR. So let's take a look. I've typed in our code for this second circle of evaluation, and when I evaluate it, we get true, which tells us that if I have an OR statement where one part is true and one part is false, the whole thing can still be true. So now that we understand a little bit about AND and OR statements, let's take a look at the next page. Now that you know how to combine tests, we will use the on-screen function to combine the safe left and safe right tests to keep Sam on the screen. So let's write the code for the on-screen function. The directions say, use the design recipe to write a function on screen, which takes in the x-coordinate and checks to see if Sam is safe on the left and safe on the right, the key word there being and. So here's the contract and purpose statement for on screen. These are already in your video game file. They're also already in the cage file for the butterfly. We need to complete 2 examples and the definition now. So the on-screen function takes in one number and produces a Boolean. The purpose of it, it determines if the coordinate is on the screen. So for our first example, the function name, of course, they told us is on screen with a question mark. We want to choose a number that represents an x-coordinate. So let's go ahead and choose the number 900, for example. What the function is supposed to do with the number 900 is it's supposed to make sure that not only is 900 safe on the left, but it's also safe on the right. So we want to use the word and here. So we want to check to see, is the coordinate 900 safe on the left? And is the coordinate 900 safe on the right? And I need to close my parentheses here. We actually are going to end up with a triple parentheses at the end of that line of code. So now that we have our first example, pause the video now and try the second example, choosing any other input besides the number 900. Here's my second example, the on-screen function using the number 355 as an input. It's going to check to see if Sam is safe on the left at the coordinate 355 and if Sam is safe on the right at the coordinate 355. So let's now circle the changeable parts of the code, which actually is in 3 locations this time. And let's give it a variable. Let's call it x, representing the x coordinate. And for my definition for this function, I want to use the name on screen with the question mark. So when I type in on screen with an x coordinate, I want the computer to check to see, is this x coordinate safe on the left? And is this x coordinate safe on the right? And that's our definition for on screen. So now back in our cage program with the butterfly, we know safe left works, safe right does not work. But now when I delete out these 2 lines of code for on screen and paste in the code that I've already written out for on screen and click run, we find that safe left still works. I'm holding down the left arrow key and he's protected. And I'm holding down the right arrow key and we also find that he's protected. He's still visible on the right side of the screen now. So we know that our on-screen function, which used and to combine safe left and safe right, we find that on-screen worked to help us protect our character. So what does this mean for your video game? Well, when you go ahead to wescheme.org and log in and open up your video game file, you are actually going to be copying and pasting all of the code for safe left, safe right, and on-screen into your video game. And what you're going to find is that when all is said and done on this page, when you click run, your target and danger shouldn't just go across the screen once and then disappear forever. They should actually keep moving around the screen. Once you get to this point, you will need to get teacher initials on this line to get credit for lesson 7. Now we're still not done with our video game. We still have a lot to do, which you can read here. But this will complete the lesson 7 packet once you get signed off on page 7.